In this section, we'll be solving systems of linear equations by graphing. Now, when I say we're solving a system of linear equations, we're actually only going to get an approximate solution. And we'll see why that is in a second. So let's take a look at the first one. Let's say we have the system of linear equations, y equals 2x plus 4, and y equals minus x minus 3. So this is our system of linear equations. We have two linear equations here. We'll call this line 1 and line 2. And we want to graph this on the same coordinate plane. So we can actually use any method that we've learned to graph the two lines on the same coordinate axis. For now, we'll just go ahead and plug in points, plug in values for each x, and solve them for y, and we'll have a few points for each line, and we can graph them on the coordinate plane. So let's go ahead and do that. Let's do line 1 first. So we have the line described by the linear equation y equals 2x plus 4. And we want to plug in a few values for x so we can find a few points on this line. So let's keep them simple. Let's use x equals 0 for one. When x equals 0, y equals 2 times x, which is 0, plus 4. These two terms cancel, so we have y equals 4, which gives us the point on the line 0, 4. All right, let's find a few more. We can use x equals 1, so y equals 2 times 1 plus 4. 2 times 1 is 2, plus 4 is 6. So we get the point 1, 6. We also can use a value on the other side of the y-axis. Let's go ahead and choose a negative point, negative 1. When x equals negative 1, y equals 2 times negative 1 plus 4. 2 times negative 1 is 2, plus 4 is positive 2. Okay, so we have the point minus 1 and 2. These are 3 points that fall on line 1. So we can graph those in a second, but first let's go ahead and take care of line 2. Line 2 is described by the equation y equals minus x minus 3. Let's go ahead. We can use these same 3 values for x right here just to keep it simple. When x is equal to 0, y is equal to minus x, which is 0, minus 3. Just drop the 0, so we have y equals minus 3, which gives us the point 0, minus 3. So far, so good. Let's pick a couple more values. Again, we can use the same ones. X is equal to 0, or x is equal to 1. Y equals minus x is 1, minus 3. So we get minus 1 and minus 3 gives us a minus 4, which gives us the point 1 and minus 4. 1 and minus 4. Okay. Let's use one more. Let's use x is equal to minus 1. So y equals minus a minus 1. We have a negative x here, so we have a negative 1. Let's be careful with our signs here. So we have these two signs cancel, and then we have our minus 3. All right, so plus 1 and minus 3 is a minus 2. So we have the point, our third point, minus 1 and minus 2. Okay, so we have 3 points on each of the lines. So now we can use these points and connect them to make our graph. So here's our y-axis, here's our x-axis. We don't talk about this much, but we want to make sure we put the arrows and label each axis. The arrows just show which the positive direction is. If we had arrows this right here and right here, that will be the positive direction, and that will be the positive direction for each axis. So we want to make sure we know the importance of labeling our axes and putting our arrows on there to show, indicate which direction is the positive direction. All right, so let's go ahead and make sure we scale this correctly to include all the points so our lines fit nicely on it. And let's go ahead and do the first one. So we have the point 0, 4, which occurs right here, 1, 6, which is right here, and minus 1, positive 2 is right here. So those are the 3 points plotted on the graph for line 1. We can go ahead and connect these 3 points with a line. Again, it doesn't entirely to scale, so let's make sure that we know that the line includes all 3 points and goes infinitely in both directions. And this is the graph of the line given by the equation y equals 2x plus 4. 2x plus 4. Okay, so let's look at the second one. We have the points 0, minus 3, which is right here. We have 1 and minus 4, and we have minus 1 and minus 2, which is right about there. Let's go ahead and connect these with a straight as line as possible. And both the domain and the range are the set of all real numbers for both lines. And here we can see where the lines intersect. Now notice, like we said earlier and in a previous video, this method only offers an approximate solution. The solution, or intersecting point, for this system of equations is actually minus 7/3 and minus 2/3. This is the point on the graph where these two lines actually intersect. Now, we can't look at these two intersections and see, well, this is indeed the point, but it only gives us an approximation. That being said, the graphing method does offer a visual representation of the system of equations where the lines, we can see the relationship between the two lines, which can be very useful for real-world applications, but it's not exact. And we actually will look at a few in some future sections actually how we come up with this for a system of equations. But for now, we're just using this as a visual representation and knowing that it's not quite exact, but we can still use it, and it's very helpful for several real-world applications. So let's just get familiar with graphing them. Let's take a look at another example. We have the system of equations y equals minus 3x plus 2, and y equals x plus 5. So these are our two equations in our system. This is called line 1. We can call this line 2. And let's go ahead and get a few points for each line so we can graph them and see how they represent, how they relate to each other. So let's start with line 1. We have the line described by the equation y equals minus 3x plus 2. Let's go ahead and plug in a few values for x, such as x equals 0. So y equals minus 3 times 0 plus 2. That cancels, so we just have y equals 2, which gives us the point on the line 0, 2. Let's go ahead and find a few more points so we can graph this line in a second. So we have y equals, when x equals 1, y equals minus 3 times 1 plus 2. Minus 3 times 1 is minus 3, plus 2 is just a minus 1. So we have the point 1 and minus 1 for our second point. And let's go ahead and get where the line crosses on the other side of the y-axis. We'll use x equals minus 1, so we have minus 3 times minus 1 plus 2. We can cancel these two negative signs, so we have 3 times 1 is 3, plus 2 is 5. And our third point is minus 1 and 5. Okay, so here's 3 points for line 1. Let's go ahead and find 3 points for line 2. Line 2 is described by the equation y equals x plus 5. And we can actually use these same 3 values since they're fairly simple to work with. And this is a very simple equation to begin with. So when x is 0, y equals 0 plus 5, or just 5. Our first point is 0, 5. We can also use x equals 1 for our next point. So x equals 1 plus 5. 1 plus 5 is 6. So our second point is 1, 6. Let's go ahead and find one more. It's always good to use positive and negative values. So we have y equals a minus 1 plus 5. Minus 1 plus 5 is 4, which gives us our third point of minus 1, 4. All right, and these are the 3 points that we find, or 3 of the points that lie on this line. So let's go ahead and plot those on the graph. So this is our y-axis, this is our x-axis, this is our positive y direction, this is our positive x direction. We can draw the scale by seeing what is the largest values for both directions for both variables. So we have 1, 2, 3. Want to make sure we have 6 on our y-axis because that's the largest y. We're just trying to learn how to scale this thing. We should be pretty good at this by now. Okay, so our first line has the points 0, 2, which is right here, 1 and -1, and -1 and 5, which is right about here. Okay, so let's go ahead and connect these dots, straight as line as possible. And this line goes infinitely in both directions. And this is the line given by the equation y equals -3x plus 2. All right, let's go ahead and plot our next one. So we have 0, 5 is a point on our line 2. We have 1, 6, and we have -1, 4. All right, so let's go ahead and connect these. Just imagine that that line goes through all 3 points. No, it's not entirely accurate. And this is the line described by the equation y equals x plus 5. Very simple linear equation. All right, so once again, solving systems of linear equations by graphing only offers an approximate solution. You can't look at this intersection and tell me off the top what actually the solution is, but I can tell you that the actual solution to this system of linear equations is -3/4 and 17/4. And which actually that looks about right. Our intersection is somewhere in this general ballpark, but this is the exact solution, while graphing just gives us an approximate solution. Again, we're only looking for a visual representation of the two lines interacting, and it's actually very, very useful in real-world situations. So we'll do some more of these in the next section, and we'll look at some other ways to solve systems other than graphing. So I'll see you in the next video.